And we also may take screenshots later in the debate. So if you do not want this, either keep your camera off or let me or my colleague Liam here know, and then we will make sure not to include you in any screenshots. The screenshots are for social media. If you're not a speaker, please turn off your audio and video for the presentation, and then later we'll ask you again to switch it back on for the discussion. If you have any questions, you may already post them in the chat, and then I will ask you later to either say them yourself or I will ask them for you. Next, please. So just to begin very briefly, a few words for those of you who don't know who we are yet. So we are the Renewables Grid Initiative. It's an association of environmental and climate NGOs and transmission system operators from all over Europe. And the aim of us, we've been working for 10 years already with the aim of promoting grid development to put more renewables into the system and do so in an environmentally friendly but also fair and transparent way. Next, please. This is just a map of everywhere we are currently situated. You see there's still some space to grow. Next. And one or two words on our offshore work. So last week we officially launched the Offshore Coalition for aligning the development of offshore wind energy with nature protection and healthy marine ecosystems. And these are the 18 founding members. We have, apart from NGOs and the transmission system operators, also the wind industry. And together we want to create a space for discussion and collaboration. Our aim is to find ways in which to plan the offshore renewable energy development better, collaboratively, across borders, across sectors, and most importantly, in line with biodiversity protection. And next, one of the topics that we want to discuss together, and this is a starting point here today, is nature inclusive design. Nature inclusive design are measures that are integrated in or they are added to the design of infrastructure, and in order to create a suitable habitat for native species. And I'm very pleased and will thank both of our speakers today, who are two pioneers in the field, both from the Netherlands, and they will share with us what their project is doing, and we are very excited to have them. So first we have Eline van Onselen. She's a marine ecologist at the rich North Sea, and she will talk to us a little bit about the topic and the context and explain the program. And then secondly, we have Annemiek Hermans, who is a biological oceanographer and marine environmental project manager at Tennet. And she will share with us very specifically the projects that they are working on currently. Afterwards, we'll have some time for questions. And yeah, with that, I would hand over to you, Eline.
Thank you so much, Johanna. Okay, so well, welcome everyone. I hope you can hear me all right. If not, let me know. So my name is Eline, and I'm a marine ecologist, and I work for the North Sea Foundation, and mainly right now on the Rich North Sea program, which I will be telling you about today. Next slide, please. But before I will tell you about the program, I'm going to go and tell you a little bit about the North Sea. This might be something you already know. It might be something new for you, but I still want to do it to give you a little bit of background knowledge into what we're doing. So first, I'll dive into the history of the North Sea a little bit, because the North Sea is actually a relatively young and quite a shallow sea. And if we go back around 16,000 years ago to the last ice age, what is now the North Sea was actually still above sea level. And you can actually see it here on this slide, that the only part of the North Sea in existence at that time was the Norwegian Trench, which is now the deepest part of the North Sea. It can reach up to 700 meters. But the rest of it was land. And only when the ice sheet started to melt the sea level slowly rose to cover more and more ground. And only around 4,000 years ago did the last of the land between Europe and Britain actually disappear. And what used to be the Dogger Island now became the Dogger Bank. But even though the North Sea filled up, and it filled up the entire area between Europe and England, the North Sea is still very shallow. And in many places, it does not exceed 50 meters in depth. And this is actually quite a unique area, and also makes the North Sea a unique area for building, also for wind farms. So this is something we always have to keep in mind. Next slide, please. So from the Ice Age and 4,000 years ago, we'll make a giant leap into the 19th century. And this map from Olsen from 1883 actually gives us an indication of the bottom habitats of the North Sea just after the Industrial Revolution. And this is a very interesting map because it shows the status of the North Sea floor before major bottom trawling altered the environment. And if you look closely, you can see the red areas indicated here. And those are flat oysters. But there are also areas with stones and rocks, as well as moorlog. And these reefs, the oyster reefs and the hard substrate, they offer settlement. They offer settlement opportunities for a lot of species, as well as a sort of living habitat or living space where species can take shelter, they can hunt, they can reproduce. So it actually offers a lot of opportunities for different species. However, the 19th and the 20th century, they also brought a lot of change to our North Sea habitats. Next slide, please. And these pictures actually indicate this change a little bit. These are pictures from the 1930s. On the left, you can actually see a Dutch fish auction with a species which is now practically extinct from the Dutch North Sea. And severely depleted in the rest of the North Sea. It's the common skate. It's quite an unfortunate name because it's not common anymore. And this skate can actually grow over 2.5 meters long. It's a very big species. Some people actually call it the North Sea manta ray because it can reach such a big lengths. But it's also a very slow grower. They only start reproducing when they're about 11 years old. And they can reach very high ages. They can get very old, 50 to 100 years. But unfortunately, such individuals are not encountered anymore in our seas. On the other side, on the right, you actually see the harbor of Hamburg in Germany, with some very large bluefin tuna. And bluefin tuna were once a species present in our own North Sea. They could grow over 3 meters long, and they could weigh over 500 kilograms. It's almost impossible to imagine this swimming in our North Sea right now. And the rising fishing industry really took its toll on these large species. They're large, they're relatively easy to track, and they're easy to fish out. So they were an easy target. However, the same fate awaited the flat oyster, for example, because it's a sessile species. It doesn't move, so it's also easy to fish out. The only need was for proper equipment, and that's something that the industry brought along with it. A strong boat and good fishing nets, and our habitats really changed. Next slide, please. However, other changes were taking place too. An example of this is the building of the Afsluitdijk in the Netherlands. We used to have a delta, but we effectively dammed it in. We made it a saltwater lake, a freshwater lake even, and we changed the salt and brackish water habitat that it used to be into a freshwater lake. Now it's a completely different habitat from what it used to be, and it effectively blocked migration for a lot of species. It eliminated suitable spawning habitats, living areas, but also hunting areas for many species. So this is something we also have to take into account. Next slide, please. So this is what the Dutch part of the North Sea looks like now, with all the human activities going on. And we actually can't see the North Sea nature apart from these activities anymore. They range from defense to oil and gas extraction, to sand and shell mining, shipping, recreation, and more recently, of course, offshore wind farms. And as you can see, it's quite a busy area. So here's the challenge. How do we incorporate nature into such a busy human-used area? We want to combine both. Next slide, please. So just to recap the previous slides a little bit, there has been a lot of change in our small sea. I'm not necessarily saying that change is a bad thing, but the fact is that a lot of change has occurred. It can't be denied. A simplified version of the connections and feedbacks of an aquatic ecosystem can be seen in this figure. And I won't go into the details, but I just want to show you this to give you an indication of how everything in an ecosystem is connected. Not only different species influence each other, but different parameters such as water depth, turbidity, waves, nutrients, they all have a direct and indirect connection to each other. And influencing only one aspect can alter an entire system. So influencing many factors can actually tip a system into a new state. It can alter it in such a way that it's not very simple to bring it back. Again, I'm not saying we should bring back the North Sea what it was like 100 or 200 years ago, but I'm just trying to give you an indication of the changes and the possible future changes that we as humans have started in the North Sea and are still starting. So next slide, please. So how can we use this knowledge to our benefit? How can we fuse nature protection and human activities? And how can both sides of the coin actually benefit and not only living next to each other? Oh, my light is going out. I'm not moving enough. Um, so, so how can they benefit from each other and actually positively reinforce each other? Maybe that would be the perfect thing. So the Rich North Sea program was actually created to establish just this. The aim of the program is for offshore wind farms to support a rich North Sea nature. The program was actually created under the wings of two different foundations, the North Sea Foundation and the Dutch Foundation for Nature and Environment. And the program officially started in January of this year, and it'll run for 4 years. And Dutch offshore wind farms and other offshore wind farms in the North Sea, they offer an opportunity as fishing and other activities are generally not allowed inside the wind farm area. And nature has a chance to re-establish there and to really flourish. Next slide, please. So on this slide, you can actually see how the program is designed. And we have made 3 different pillars to combine science, to combine industry and policy for creating a widely supported new standard. Because that's what we want to do. We really want to make nature enhancement in offshore wind farms the new standard. We want to integrate it. We want to integrate all these pillars into one and make it the new normal, as we say here right now. And we want to achieve this by doing pilot projects to create a larger understanding of nature development and also possible enhancements within offshore wind farms. And we are currently working together with 6 industry partners. You can actually see those on the left side under projects. And we're working on different projects in the North Sea, either in existing wind farms or wind farms which are being built right now, or which will be planned and built in the coming years. And examples of the projects are experiments with artificial reefs, different substrate types, but also placing flat oysters, for example, to create new reefs. And monitoring is an important part of these projects. And next to these projects, we also support scientific studies We work together with other North Sea countries, and we try to stay connected to new research in the same area. So in the middle pillar, you can actually see that we also focus on innovation. We are working on a flat oyster hatchery for our own source material. We rented a plot 12 kilometers offshore for experiments with artificial reef systems. This is the North Sea Innovation Lab, as we call it. And we are also promoting innovation in design of artificial reefs, but also in nature inclusive design and in monitoring techniques, because these are really crucial for the upscaling of the industry. And at the end, on the right side, not unimportant, this pillar focuses more on lobby and communication, both on a public and a strategic level. And all the results from all three pillars, both scientific and practical, will be published in an online environment. And we call this the toolbox. And the toolbox will be available to all interested parties. Everyone who has internet will be able to look it up. And this will offer practical information for implementing nature inclusive designs into offshore wind farms, as well as its scientific background. Next slide, please. So this slide gives a little bit of an impression of what we've been doing so far this year. And it ranges from placing artificial reefs. For example, in the middle, you see the artificial reefs, which will be placed next to a platform from Tennet, which Annemiek will talk about later. But we also have oyster racks. We have multi-beam data analysis. You see some ROV footage. We've been testing artificial reefs in a flume. So there's already a lot going on. Next slide, please. And this map actually indicates the location of our project, including the existing wind farms, as well as the wind farms which are being built or planned. And on the side, you see some pictures. Actually, on the bottom, you see some young oysters from the hatchery this fall. So we're definitely not sitting still. We're also doing some cross-border work already. We're working together with the UK and Belgium on some projects. And we really want to go further with this, as the North Sea nature does not end at its borders. Next slide, please. So just as a recap, well, the North Sea has been changed in the last 200 years, and it will change even further with the outroll of wind at sea. But the North Sea, the Rich North Sea program really looks at this as an opportunity to combine human use and nature enhancement. And I think if we work together, and working together is crucial on this, we can really profit on all levels. So thank you for listening.
Thank you. Yeah, we can go straight ahead, please, Annemiek.
Thanks, Eline. That was very insightful. And as Tennet, we're very pleased to be a part of your program. My name is Annemiek Hermans, and I'm a biological oceanographer. And I'm going to tell you how we include nature in our designs at Tennet today. Next slide. First of all, a short introduction to Tennet for those of you who don't know us. Next slide. So here are some of our core numbers. We have about 5,000 employees, and we're working on reducing our footprint. We already have over a quarter of our activities greened, as we say. And our grid length is over 23,500 kilometers, ranging from the Dutch and a part of so the whole of the Netherlands, and also part of Germany. Next slide. So here you see a map of the grid that Tennet has under control, so to speak. We supply the Dutch and part of Germany, both onshore and offshore, and also we have a number of interconnector cables, which you can see running from the Netherlands to northern countries, but also to the UK. Next slide. Today, what I want to focus on is the Dutch continental shelf. You may remember the map that Eline just showed us with the planned and current offshore wind farms, and these are the cables that run towards those offshore wind farms, where we transport the electricity from the generated offshore from the platform through the export cable towards the land. And there are a couple of extra cables. Those were placed before Tennet was responsible for the offshore grid. So they're under the ownership of the offshore developers themselves. Next slide, please. So we have, as I think many of our audience today, the ultimate challenge to balance the grid. First of all, it has to be reliable and affordable. And if we have those two under control, we also want to make it sustainable. That's where our CSR our CSR policy, corporate social responsibility, comes into play. We have 3 ambition areas: circular, climate, and nature. Today I will be focusing on nature. Next slide, please. Now, when we started to develop our CSR policy for the offshore grid, we looked at 6 policy goals. You can see those above the waterline. And on the most right, you will see what we call the 2 policy goals for nature. So reduce our environmental impact, but also enhance nature where possible using our offshore assets. And we do that by implementing by implementing ideas through 5 steps, which you see below the waterline, going from the left to the right. In the first step, we build up the knowledge required to then run pilots, integrate them in projects, and when successful, we include them as a standard in the offshore grid. Next slide. And we started doing that around, well, a couple of years ago. As you know, in 2016, the Paris Climate Agreement was signed, and also the Dutch Energy Agenda was formed. So that was sort of also formed the baseline of the starting queue for Tennet to start developing the offshore grid. And in 2017, we had a lot of stakeholder discussions with NGOs, part of which Need the Rich North Sea, but the North Sea Foundation that Eline is part of. And that resulted that in 2018, we started with an inventory of our nature inclusive design possibilities for the 700 megawatt concept. So those were for the AC cables that were under development. In 2019, we got a mandate. As you may know, Tennet is 100% owned by the Dutch government. So we have to also have a financial mandate to spend money or allocate resources towards this specific goal of nature inclusive design. And in 2019, we had a commitment from our institutional stakeholders, and also internal commitment from the parties that were responsible for allocating budget to start the project rollout that we are in now in 2020, and will continue for, well, a couple of years at least, until everything that is successful is also part of the standard grid. Next slide. So what really helps for Tennet is that the development framework for offshore wind, which is set up by the Ministry of Economic Affairs and Climate, that they have provided us with this mandate. I know this is different in different countries, but on the right, you see what's actually the actual formulation of the mandate in Dutch. but basically it states that we should incorporate nature in our designs as much as technically feasible, as risk-free, within a cost that is comparable to the offshore wind farm developers, and that are applicable under project-specific circumstances. So because this was is now incorporated in our assignment from the government, so to speak, this really helps with starting with implementing the different ideas in the different projects. Next slide. Now, what are specifically our nature inclusive design measures? Here you see an overview of the different. We have 4 sections identified in which we have nature inclusive design measures. If we start on the left, first we see the offshore platform, the jacket, where we have fish hotels or biohuts that are attached to the jacket, that allow for juvenile fish and crustaceans to grow and to shelter in a sheltered environment, so that they hopefully increase in biomass and have a larger opportunity for survival. We know, for example, that already cod and other species use the shelter of the jacket to preserve energy, but we hope to increase that function. We also have artificial reefs. That is what Eline just showed us in the picture. Here you see what it's not a great visualization, but it should be a reef ball. But the first ones that are going in now in Borselen are actually reef cubes from Arc Marine. And we're looking at eco-friendly scour protection, where we understand that smaller rocks used in scour protection also allow for some loss of rock and also movement, frequent movement, which reduces the opportunity for a reef and reef associated species to make use of this habitat. So larger rocks will reduce this movement and therefore create a better habitat. So these are the 3 different nature inclusive design options we have in and around the jacket. Especially the artificial reefs are within the 500-meter safety zone from the jacket, which ensures that there are no other activities that might disturb the artificial reefs. And we've placed them in an area where there's no cable activity, and also that's not designated for example, a jack-up barge when any maintenance is required. Then in the second area, we have the eco crossings, as we call them, basically cable crossings, where the cable has to cross an existing cable that's already there. And that normally the cable is buried in the Netherlands. Within the first 3 kilometers offshore, you have to bury your cable a minimum of 3 meters, and after that it's 1 meter. But at these cable crossings, they are above the seabed, and rock is used to protect the cable. And now we're running a pilot. We're currently running a pilot in which we have used a different type of rock. Normally we have granite, but this is a marble rock, which is a calcium-based rock. And early studies have indicated that this might provide a better settlement area for different types of larvae. And we have 3 cables that are traditional and 3 cables that are with this type of rock. And we're going to see if this provides a better habitat. And then the third one, ecological landscaping. When we have cable joints on land, this is still part of the offshore grid within Tennet, so it's actually onshore, but we see it as offshore. And here we have ecological landscaping, which is basically using different types of vegetation, but also bee hotels, nestkasten, bird housing, I think. I should have looked it up. I'm sorry, bird housing. And to make sure that we, this is a small scale measure, but that we locally enrich the biodiversity where we have an influence on, where we either own the ground or have a long-term lease. And then the last area is the land station, where we transform the electricity that comes from the offshore grid to the land, to the onshore grid. And here we have a coastal breeding area, a coastal birds breeding area, sorry. The idea is that, especially for ground breeders, there's not a lot of space to breed. And also where there is space, there are a lot of predators like fox and rat and cats even. So because the whole area is fenced off with a fauna protecting, fauna deterrent fencing, birds can use the area freely for breeding without being preyed on. And also when you demarcate a specific area, research has shown that the chicks stay inside, and there's actually less interface with breeding pairs, breeding parent pairs and maintenance staff. So the birds stay where they're supposed to stay, and they do not provide any hindrance. And again, the same ecological landscaping, which I've explained before, but then on the land station. So these 7 items, these 7 nature inclusive design measures, we are now including in the offshore grid, which includes a little bit of onshore grid. And some of them are in pilot phase, other ones are in planning phase. And the idea is that for each project that we do, we bring them a step further so that in 2030, they're all part of the standard grid for Tennet. Next slide, please. So here you can see how far we are, so to speak. So these are all the projects in the Dutch waters that are currently being executed or being planned, where we start with Borselen, then Hollandse Kust Zuid. Then we have a Noord, Hollandse Kust Alpha, West Alpha and Beta, ten noorden van de Wadden, which is all the way in the north, and IJmuiden, which is the first Dutch DC project. And the numbers indicate which of the nature inclusive design options, shown again on the right, are included. And as you can see, Borselen was the first, we only have 1. And then for Hollandse Kust Zuid, which is the second, we have 3. And then we build up until hopefully they become standard for all the projects. Next slide. Now we don't do this together. We do this together with Elina and her colleagues. We work with Nature and Environment and with the Dutch North Sea Foundation through the offshore, through the Rijke Noordzee, so the rich North Sea, for specifically for Borselen and possibly also for other projects. Next slide. And we're in discussion with a lot of other stakeholders that provide us with input or ask critical questions or keep us sharp through consultation sessions to ensure that we stay on the right path. So this includes the presentation. This concludes the presentation with all of our different options. And if you would like to know more of a specific option, we're very happy to share. Thank you.
Thank you very much. Yeah, this is perfect. So now we have some time for some questions, and I would invite everybody to switch back on their video so we can see each other. If you want to see everybody in a grid, at the top right you have a view button where you can change it to a grid so you don't only see me. So thank you very much for these presentations. We already have a couple of questions in the chat. So I will, yeah, some of them are not that easy to answer, of course. But so the first one is the fish hotels. Are there a specific type of species of fish that you want to attract with this?
Yeah, so we're now looking at juvenile cod. to begin with, and they can be adapted to different species depending on the material you use to fill them. They are filled half with, for example, oyster shells or rock, and the cavity sizes between the material obviously provide different sizes of shelter, and a part of the grid is empty. So, but also the mesh size allows for different sizes of species to come in. So for borstelen, we're focusing on juvenile cod, and also so they're placed low on the jacket because they. Oh, sorry, I shouldn't say for borstelen. I should say for Hollandse Kust Noord, my apologies. They're placed low at the seabed because we understand that cod like to live close to the seabed, but they can be adapted to different species depending on where in the North Sea you are.
Just because it's related to this, do you have any reports or detailed information on specifically the fish hotels and artificial reefs?
Well, we have information from the supplier of the fish hotels. It's a French company, BioHut. They have some experiences with fish hotels in the Mediterranean and also in an eastern sea. I forget which one. And they on their website the results of those projects are shared. And for artificial reefs, we also rely on the suppliers. And I think I have to defer that question to Eline because she will be able to answer that, I hope.
Partly, I think. There is actually a lot of information out there, but most of the artificial reefs that have been implemented have been in tropical areas. And North Sea is quite different, of course, because it's both a cold water area and it's also a very dynamic area. So not a lot of published scientific articles are out there yet. But well, we're working on it, definitely. And of course, there is some information out there available. There is a lot of information available, for example, on different species and their habitat requirements. And that's something you can always take in a parallel when you are designing or implementing artificial reefs. And also, when we look at species which are being actively fished upon, for example, there's a lot of information on those species out there as well. So it's both pioneering and piloting, but it's also scraping together the data that's already there and combining it into what we need.
I want to actually give the audience the chance to also speak. So going in the order of the questions coming in, Erwin, would you like to pose your questions about the aim and possible negative effects?
Yes, hello. Yeah, I was wondering what the goal is that we want to achieve. Of course, I understand it's good to increase the richness of the North Sea. I agree with that, but what do we want to achieve, and what do we gain with it with us all? That's the first question, and the other one was can we expect some negative results, like do we might attract fish from other seas or neighbor countries where they which they were not expecting to come our way? Those are my questions.
You. Do you want me to give a
Yes,
response
please.
to that, Jana? Very good questions. And I think the first question is actually quite hard to give a definite answer to, because there are a lot of opinions out there, I would say. There's a lot of rules to navigate, a lot of different policies, especially if you want to look at the entire North Sea. Of course, we have different countries with different regulations. And most of the North Sea countries also have goals which are not exactly the same for their part of the North Sea. So this is definitely something we have to work on and really, cooperate with each other on to gain this this common interest and this common goal, so to say. And I think it's very hard to say exactly where we want to end up, because as I said during my presentation, I'm not sure if it's possible to go back to the North Sea as it was. But the question then also is, do we want to do that? Because we as humans have a lot to gain from the North Sea. There's a lot of human activities out there because, well, there's a lot to gain from it. But I think it is, well, consensus right now that that we don't want nature to degrade even further. There are a lot of species which have potential in our North Sea. It doesn't necessarily have to be commercial species, but they can be well, interesting species and biodiversity as a whole. And I think we should protect what's there, and we should nourish which could be there, which we know was there. But what exactly that is, it's very hard to say, well, we need 2,000 cod in this area, or we need, you know, 100 lobsters there. So I think it's more of it's more in line with setting boundaries into the direction that we want to go in, instead of exactly saying the number and things like that. So we want to make it a habitat instead of a garden, if you know what I mean. I hope that answers your questions a little bit. I can't answer it fully, but I think it's a good point of discussion.
Yeah, but I think the answer is good. Thank you for that part. Yeah.
Peter Genge also from Tennet, you have a question on decommissioning, which is important but difficult.
Yes, thank you. Thanks, Johanna. And thanks also for the two presentations. Yes, I work for Tennet in the CSR department, and I was wondering what happens after the after the life cycle of these offshore platforms. Are these positive measures going to be removed as well, or yeah, it would be pity actually, but I don't know if you have any hints on this aspect.
Yeah, Anna, would you like me to respond?
Yes, I'm not sure. Yeah, whoever would like to.
Well, I'll try. I'm sure that Elina has some additions, but Peter, yeah, you're right. This is a very interesting subject, and currently, at least for Dutch law, everything you put in should be taken out, as you know. So one of our design requirements for any nature inclusive design a measure is that it has the same lifespan as the asset that it's being integrated on, so that we don't have any no maintenance or decommissioning requirements during the lifetime of the asset. And we're actually discussing also with the Rich North Sea, which hopefully is going to lobby on our behalf to see if we can leave in certain aspects. This discussion has been going on about 30 years. It first started up for the to leave oil and gas platforms, well, at the time it was believed that whoever pollutes should pay, so to speak. So if you spend a lot of money putting it in, then you can also spend money getting it out. We hope now that by showing the different developments on an artificial reef or on a cable crossing, that it actually is a real loss to environment or biodiversity or ecology to remove it. And we see also, there was actually an article today in the Research from the Wageningen University that again shows by a researcher, Joop Kolen, what different types of biodiversity can be, different species that can be stimulated, and what an addition that could locally be. So there are discussions, but it is going rather slowly, and also it's very country specific. Does that answer your question a little bit?
Yes, thanks a lot.
Can I maybe add to it a little bit? Yeah, because I think, and I totally agree with what Annemiek is saying, and but it's also twofold in what we're trying to accomplish in the rich North Sea. Because with the rich North Sea, we really want to try to kickstart nature, so to say, and nature will take over at some point. So the aim is to not being dependable on those artificial substrates anymore. And we can do this in two ways. Either we design a biodegradable reef, which degrades after the asset has also been removed. So let's say 20 to 30 years. But we could also say maybe after 20 years, if we do it right, the natural reef is so big, it doesn't need its original asset anymore. And that's why we really want to be active in stimulating the reef as well. If we would do nothing, you still have hard substrate in the form of your turbine and your scour protection, for example. And a reef would grow, but it would grow quite slowly. But if we can enhance it by placing artificial structures in the right places, then maybe we can help the reef develop faster. And at some point, maybe after 20 or 30 years, the reef is big enough to be able to stay established. And if you remove the original structure, it'll still be there.
We have Inne Withoek. Would you like to pose your question yourself on eco-crossing pilot side?
Hi, yes, thank you. So I'm doing a PhD on studying fisheries interaction with energy infrastructure. So I was wondering, in terms of the cable crossing pilot, whether there was any results already comparing granite and marble and how it affects larvae settlement, and also whether there's a big price difference in buying granite versus marble. Thank you.
Hey, Ine, that sounds like an excellent PhD. I hope that you're having fun. Well, the reef went in a month ago, or I should say the reef. I apologize. The different type of rock. So the pilot started a month ago. So no. I do know that Van Oort, a marine service provider, I think they're called, or a dredging company in the Netherlands, they have recently done some research on this, and they have indicated that we did the pilot together with Van Oort, or they executed it for us, and they have some homegrown research where they show that the marble rock is a better settlement option. So I can bring you in contact if you want with them. They might have some data for you. I'm not sure if they're willing to share, but you can always ask. And as opposed to costs, in this case, it was quite expensive because we thought of it already after we set the contract. That is one of the big lessons learned, that if you include the requirements before you set the contract, then it all goes a lot smoother and everyone works a lot harder than when you do it afterwards. And also it depends on, so in our case it was more expensive, but the actual rock isn't more expensive, but sometimes you have to go to a different quarry to get it, and then you have a longer sailing time, and that might have a cost implication. And also what we found, but that was because we had a lower amount of, we only had 3 crossings, is that when you use a larger side a larger stone dumping vessel, then you only have big holes to place the rock, and sometimes you need there's the bone is not suitable for 2 types of rock. I'm not sure what the bone is in English. The hull, I think. So that could also be thanks. That could also be a cost implication, but it depends on the vessel that is used. So not necessarily, but depending on the circumstances. I hope that answers your question.
Yes, thank you.
Before I let the next audience member ask the question, I wanted to just pass a question from the speakers to the audience. They asked me whether there's anyone who would like to share their own experiences. Maybe you already have pilot projects in other countries. If you do, please indicate, and I'll ask you to indicate it in the chat, and I'll ask you to speak. But moving on with the questions for the speakers, we have one from Carla Kuman. Are you here? Would you like to? Yeah.
Yes, thank you. Unfortunately, I don't have a camera, but and thanks a lot for the presentation. I was wondering, and this is what I wrote also in the chat, why you consider it useful or necessary to add additional artificial reefs next to the piles from the wind farm, which are basically hard substrate and could be considered some sort of reef already. So what is the difference, so to say, with the artificial reefs in contrast to the already existing structure, and why do you have chosen to add more hard substrate to the wind park? Thanks a lot.
I think I can start answering the question, and maybe Annemiek can add to it later. I think I already answered it a little bit with the previous question, is that we really want to promote the reef building species. And sometimes just having hard substrate in the form of a wind turbine and scour protection is not enough. It might not be the optimal environment that we want to be able to offer. I'm not saying the hard substrate that the assets have is not suitable for a lot of species, but I think it can be optimized. And I think right now with the artificial reefs, we are really experimenting with what works and what doesn't work, of course, as well. But the goal is also at some point to really integrate it into the design, because there is such a large outroll of offshore wind going on, and we really need this to be scalable to the large sites it's going to be. But right now, the things that we're doing is really experimenting with different designs, different materials, and seeing what works best. And of course, at some point, we also have to make a decision on when it's enough. When do we have enough substrate in the North Sea? Enough hard substrates? When do we have enough reef species? And that's something we all have to think about and really discuss internationally as well.
I have two questions here from Karen from Ireland. It's a shame that your microphone isn't working, but I will ask them. So they said, our existing Irish wind farms have some interesting kelp habitats. They develop without any special design. Have you got any inventory of habitat development around existing Dutch wind farms? And also, is there any info and response of sharks and rays to the wind turbines? They have wind turbines that are now targeting sandbanks where spawning aggregations are known to concentrate. Who would like to answer this?
I think the kelp question is definitely a good one, but it's not, as far as I know, a native habitat in the Dutch North Sea. So we're not experimenting with that as of yet. It might be a very nice international project, though, so I'm very open to discuss this further. I think the sharks and ray question is right up Annemiek alley, so I'll pass it to you.
Thanks, Eline. Yeah, we don't currently have a lot of information about the response of sharks and rays to offshore wind farms, but actually, I'm doing a PhD on the effects of electromagnetic fields on elasmobranchs, so sharks and rays. And one of the aspects is that we're looking at the differences of diversity and size of sharks and rays within offshore wind farms and without. And we are going to do laboratory experiments to see if electromagnetic fields resulting from the offshore cables is a factor in shark and ray distribution. Also, there is some research that electromagnetic fields have an impact on the development of embryos, so shark and ray eggs. And I think that would be interesting for you to read if you're looking at the impacts of, nursery habitat. But so more information is coming, but is not yet available. I think.
Okay, we have Niels Kinneging. Maybe it's the last question. 3 more minutes.
Okay, well, thank you for your presentations. And I missed, especially a question for Eline is on the involvement of government and especially the connection to the WOZEP program, Wind at Sea Ecological Program, a research program from the Dutch government. Can you comment on that?
Yeah, definitely. Well, within the North Sea Foundation, we have actually made a sort of a split between the opportunities of wind at sea and the risks it brings. And the part about the risks is more connected to WOZEP and also KIC, which is about accumulation. And I think it's up to us now to also make the connection between mitigation and opportunities. I think it's a very good thing to think about because they are very closely connected, and I think there's also a lot of chances there to not only mitigate negative effects, but then make it into a positive effect, so to say. But yeah, we definitely are looking at WOZEP as well, but more on the risk side. Does
Okay,
that
thank
answer
you.
your question?
Yes, it does. But we speak to each other later.
Definitely.
Yes.
Right. There's on that note, there's a lot of questions coming in, and I'm super happy to see that there's so much interest. If you have any more questions, you can always contact me, and I will forward them. And yeah, I think these projects are still at a very pilot phase, so there's still a lot more that we can learn from them, and we should exchange internationally on them to learn from each other. And with that, I would close it today and give a very warm thank you to everybody who participated. Also very much to the speakers who took time to explain their project to us, and to Liam for supporting me today in setting this up. So thank you very much, everyone, and have a lovely afternoon. And we will publish this on our website. And as I said, any more comments, get in touch. Thank you. Bye-bye.
Bye, everyone.
Bye-bye.
Okay, bye.
Thanks, Joanna, for organizing. Most excellent.
My
Thank
pleasure.
you
Totally
very
agree.
much.
And
Bye-bye.
thank you for moderating. Very well done.